Hey everyone, how's it going? In this video, we're going to expand our definition of what a limit is and talk about the two different types of limits. So, if we think back to what we did in the previous video, we found the limit as x approaches 2 of 4x plus 5. Now, what I didn't mention in the previous video that we're going to touch on now is that this limit can actually be written as the sum of two other limits. So in the previous video we had our graph going like this, and we wanted to find the limit right here at x equals 2. So what we did, we went from numbers that were bigger than 2, we tried like 3, 2.5, we tried numbers like that, and we slowly approached the number 2. So you might be thinking, why didn't we try numbers like 1.5? Why didn't we try 1.9? Well, we could have. And this represent the two different kinds of limits. One limit comes from kind of the more positive side. So if we think about what numbers are to the right of 2, well, those numbers are more positive. And what numbers are to the left of 2? Well, those numbers are more negative, or they're smaller. So here we have the idea of having two different limits. We can have the limit as x approaches 2 from the right of 4x plus 5. And we can also have the limit as x approaches 2 from the left of 4x minus 5. So when I write this little plus sign right here, that just means I'm coming from the right to whatever number I want to find the limit at. And when I write this negative right here, that just means I'm going from the left to the number that I want to find the limit at. And only if this limit is equal to that limit can I write a statement like this. So right now we're going to work on an example of finding both the left hand and the right hand limit. So right here I have the equation graphed 4x squared minus 3x minus 10 over x minus 2. All right. So that's a lot of plugging in if I wanted to find the limit. So what I'm actually going to do, I'm going to try factoring the top first. Well, the top factors out to 4x plus 5 times x minus 2 over x minus 2. And this is just the basic factoring. I'm seeing what numbers multiply to give me negative 10, and what numbers add up to give me negative 3. So now that we have that, I see we have an x minus 2 on top and on bottom. So, well, I can just cancel these out, right? Okay. So now I'm left with 4x plus 5. It's pretty much the same equation that we had in the previous problem. Okay. Now if I plug 2 in here, I get 4 times 2 is 8, plus 5 is 13. Alright, that's cool. Problem's over. And as always, happy studying. Just kidding. What happens if we plug 2 in here? Well, if we plug 2 in here, then we get 2 squared is 4, times 4 is 16, minus 3 times 2 is 6, minus 10, over 2 minus 2. So 16 minus 6 is 10, 10 minus 10 is 0, 2 minus 2 is 0, and this does not work out because we can't divide anything by 0. So obviously there's a problem with just plugging in 2. And as you can see, that's the reason why we actually have a hole in the graph right here. So if we can't just plug the number in, we're going to have to find the limit to see what the graph is approximately equal to there. So let's take the left hand and the right hand limits. Okay, first let's find the limit as x approaches 2 from the right of 4x squared minus 3x minus 10 over x minus 2. And to do this, I'm going to plug in, once again, some values that are greater than 2, but are slowly approaching it. So I'm going to try x equals 2.5. I'm going to try x equals 2.1. And I'm going to try x equals 2.01. Now you can work this out on the calculator. I did it beforehand. So when we plug 2.5 into this function, we get 15. When we plug 2.1 in, we get 13.4. And when we plug 2.01 in, we get 13.04. And now I'm going to find the left-hand limit. So the limit as x approaches 2 from the left of 4x squared minus 3x minus 10 over x minus 2. Once again, I'm going to try plugging in various numbers, but this time, since we're coming in from the left, I'm going to use numbers that are smaller than 2, but are getting closer and closer to it. So I'm going to try 1.5, I'm going to try 1.9, and then 1.99. Now again, I worked this out previously, so I'll just write what the answers are. When we plug 1.5 in, we get 11. When we plug 1.9 in, we get 12.6. And when we plug 1.99 in, we get 12.96. So now let's take a look at these piece by piece. What does the right-hand limit look like it's approaching? Well, it went from 15 to 13.4, and from 13.4 to 13.04. And you can imagine getting closer and closer to 13. So this is approaching 13. All right, what about the left-hand limit? Well, we were increasing from 11 to 12.6 to 12.96. And that also looks like it's approaching 13. So as you can see, these two limits, they're equal to each other, which means that we can combine these two, we can combine them, and give kind of like an overall limit. So our overall limit, we're not going to have a left hand or right hand approach now. We're just going to have the limit as x approaches 2 of 4x squared minus 3x minus 10 over x minus 2 equals 13. So what this is telling us that if we graph 4x squared minus 3x minus 10 over x minus 2, then as x gets closer and closer to 2, regardless of whether we come from the left side or the right side, we're going to be approaching a y value of 13, even though technically there's a hole at x equals 2. I hope this video helps. If you have any questions, let me know. And as always, happy studying. I just wanted to say that if you're struggling with any of your schoolwork, whether it's just a single question or a concept in its entirety, then please feel free to just comment here or send me a message, and I'll take a look at it and I'll do my best to send you a video back explaining whatever you're having difficulties with. Thank you.